Okay, so this is part 2 of the lecture number 1. In this video we will do some examples. Okay, look at the first example. Here we have integral of 2 divided by x square plus 3x minus 4 dx. So we will have to integrate it, but since we don't know the integral for this, or let's consider it is difficult for us to integrate this, so we will factorize this equation first, this function first. So to factorize this, let's see how to factorize it. We have x square plus 3x minus 4. So method for factorization is to look at the constant number here and the coefficient of x square. So we will multiply that. The coefficient of x square is 1. So write it here, 1 multiplied by the constant term, which is minus 4. So write it here, which gives us minus 4. Okay, so now we will look for two numbers which, when we multiply, give us minus 4, and when we add them, we get plus 3, the coefficient of x. Okay, so I believe when we multiply 4 multiplied minus 1, we get minus 4, and when we add them, like 4 plus minus 1, we get 3 plus 3. Okay, so these two are our desired numbers. We will write it here. X square will come at its place, then 4, so we will write 4x, and then minus 1, so we will write minus 1x, and minus 4 will come at its place. Okay, so if you look at these two terms, we get x is common from these two, and we are left with x here plus 4 here. Close the bracket, and look at these two terms, we get minus 1 is common, and we are left with x here plus 4 here. Okay, plus 4 is like when we take minus 1 common from here, so we are left with plus 4 here. Now these are two terms, this and this, so we will take x plus 4 common from this term and this term. Okay, so let's take it common, x plus 4, and we are left with x minus 1. So these are the factors we got from the main equation. Okay, so look at the screen now. These are the factors we got, x minus 1 and multiplied by x plus 4. These are the factors we got, and we will now proceed with our method of partial fraction, which is, if you look at our index, look at the first type. We will look at the denominator, right? So in the denominator, when we have linear factors, two or more linear factors, then we will take the partial fraction decomposition as a divided by x plus a plus b divided by x plus b, and so on, like this. So here we have two linear factors, x minus 1 and x plus 4. Take it as x minus a and x plus b. Okay, these are linear factors, so we will take the decomposition fraction as a divided by x plus a, or here it is x minus a. To be more specific, here it is x minus 1 and plus b divided by x plus 4. Okay, so to proceed, we will have to multiply both sides with the denominator term at the left. The denominator term at the left is x minus 1 multiplied by x plus 4. So we will multiply this whole equation, means this side and this side, we will multiply it with this. So at the left side, we will this denominator terms, all the denominator terms will cancel out, and here we will do a simple multiplication. So if you can see it is it is multiplied here. So this term x plus 4 is cancelled with this, and x minus 1 is cancelled with this, right? These terms are cancelled out, and in the right side of the equation, we will have to multiply it with the terms progressively. So the terms x minus 1 multiplied by x plus 4 is multiplied with this a divided by x minus 1, and it is also multiplied by this b divided by x plus 4, right? As you can see here. So and in this equation, if you see, x minus 1 can be cancelled out with the x minus 1 of this term, and x plus 4 is cancelled out with x plus 4 of this term. Okay, so we are left with 2 equals a. Okay, right? 2 equals x plus 4 multiplied by a plus x minus 1 multiplied by b, right? It is written here. So look at it. 2 equals a multiplied by x plus 4 plus b multiplied by x minus 1. Okay, so now these are unknowns, a and b, so we will have to find it, and a method for it is to put a point in the equation. Okay, so we will put x minus 1 equals 0, and in the second time we will put x plus 4 equals 0. So first, when we put x minus 1 equals 0, x minus 1 equals 0. So when this 1 goes to the other side and we get x equals 1. So when we put x equals 1 in this equation, we will get this term as 0, right? Look at if you can see x equals 1. So when x is 1, 1 minus 1 is 0, and this x will become 1 as well. So 1 plus 4 is 5, right? 1 plus 4 is 5, and 1 minus here is 1 minus 1, which is 0. So this term will become 0, and we will get 2 is equal to a multiplied by 5, right? Here you can see 2 is equal to a multiplied by 5 plus 0, and this is the final equation we get. And so when we shift the 5 to the other side, we get a equals 2 divided by 5. Now this time we will put x plus 4 equals to 0, by which we will get x equals minus 4, and we will put it in the equation b, equation named b. In this equation we will put x equals minus 4, and so we will get by the same method we will get b equals 2 divided by minus 5, okay? Or you can say b equals minus 2 by 5, okay? Now by putting the values in the equation, put values of a and b in the equation, the main equation. What is the main equation? This equation, 2 divided by x minus 1 multiplied x plus 4 equals a divided by x minus 1 plus b divided by x plus 4. We will put the value of a and the value of b, so we get, okay, so we get this is the value of a and this is the value of b. So by simple mathematics we get this these terms, and we will put this final result and the main integral. In place of this we will put all the terms. So right, you can see this is the main integral, 2 divided by x minus 1 multiplied by x plus 4. This is the main integral, and we will substitute it with this term because we have calculated it, which will give us integral these whole terms and dx, okay? So if you can see now, this is now a relatively easy term to integrate, and this is also an easy term to integrate. This has been decomposed, and we have now 2 divided by 5, a constant term, multiplied by 1 divided by x minus 1. This is the main variable term which we will have to integrate, and in the same manner 2 divided by 5 multiplied by 1 divided by x plus 4. We will have to integrate this variable term. So by integration laws we will get this constant term out of the integral, and this constant term as well out of the integral. This will come at its place, okay? This is simple mathematics. And now according to integration rules, we will have to find a differential of this x minus 1 term, and we will check if it is present in the denominator. The same as this, we will have to check a differential for this, and we will check if it is present in the denominator. So when we differentiate this, when we differentiate x minus 1, we get 1. Like when we write dx divided by dx, we get 1, and we write the differential of constant of any constant is 0, so it will become 0, and we will get 1 the whole out of it when we differentiate it, okay? See this, okay? So when we differentiate this, we get 1. This is 1, so we will write the differential of this x minus 1 in the numerator like we have written it here, okay? In the same manner, when we differentiate this, we get 1. How? When we write d by dx whole x plus 4, d by dx of x is 1, and d by dx of 4 is 0. So we get 1 from the whole differential of this term, 1. You can see this is 1, so in place of 1 we will write d by dx whole x plus 4. In place of 1 we have written d by dx whole x plus 4, and by differential laws, by integral laws, we get okay, so this constant term will come at its place is 2 by 5, and the integral of x minus 1 is ln x minus 1, and minus 2 by 5 will come at its place, and the differential, the integral of x plus 4 is ln x plus 4, and we will eventually have to write a constant c to indicate that here may or may not be constant term present. And in the next slide, we took 2 by 5 is common, and we are left with ln of x minus 1 minus ln of x plus 4 and plus c. And by logarithmic rules we get, okay, so this 2 by 5 will come at its place, and by logarithmic rules we will get ln of x minus 1, and this will come to the denominator and plus c. So this is our final answer, and that's all for the video. Bye.